this symmetric matrix and X is a column vector from R cube, which one of the following statements is R2? This question is easy to solve in the exam if you have done this already, okay? Otherwise, you have to work a little bit, but you could solve this in the exam, okay? All you need to understand that the maximum of this will be equal to this. Y transpose, suppose the matrix is A here, okay? Y, where norm Y is equal to 1. And this kind of question I had already solved in TIFR. I mean, this is asked in TIFR 2024, maybe. I don't remember exactly the year. So maybe it's 2024 or it might be 2025. But this kind of question is in the part A, where I have solved it. This is, part A, number 13. Okay, this will be in the playlist. You can check it out. And where I had told you that this thing, X transpose for a symmetric matrix, X transpose X, where X is a non-zero vector, is equal to what? Max of this is equal to the maximum eigenvalue of lambda. And same kind of question with this same concept from the same concept has been asked in the GATE 2026 exam also, okay? And if you know this, then you could solve that question quickly in the exam and also in the CSIR-NET, okay? So it's very important to solve all the recent year exams. So of TIFR, GATE, CSIR-NET, you have to solve from everywhere, okay? So let's start. So see, you have to find this. Suppose you want to find this for any matrix, max of X non-zero, X transpose, M is a symmetric matrix, okay? X transpose X. First of all, observe that this is equal to this, because if you divide by norm X square, so this is a maximum of a set, okay? So see. So let me do it roughly. Norm X, X transpose X. Norm X, okay? So this is going to be, this number is going to be where X is a non-zero vector. Let me know. What is this going to be? This thing is 1, right? And this comes out to be X transpose, and this is a unit vector, okay? Let us denote it by Y, M, Y, right? All of you can see it. So this is a, real number. First of all, note it, okay? Yes or no? X transpose X is a real number and X transpose MX is a real number. So their quotient will be a real number. So you can rewrite this number like this, okay? So I can, Y means, where Y means X transpose divided by X divided by norm X, okay? So this is a unit vector. So those who were watching this solution in the YouTube video can check out the notes in the description, okay? So in the description, I will in the notes, I will be writing this all fully. मैं सबको अच्छी तरह लिख रहा हूँगा, so you can check it out. And to watch the complete solution playlist of CSIR-NET, you can subscribe our channel. You can join our channel with the membership of 179, okay? So this means that this thing, max of X transpose MX X transpose X, where X is a non-zero vector, is equal to max norm x equal to 1, x transpose mx. So all of you understood? सबको समझ में आया? किसी को नहीं आया तो पूछ लो, मैं और करके बता देता हूँ. Once you understand this, then it's very easy to solve. Okay. So what does this mean? This means that max of this set x transpose x and the maximum is attained. Okay. Why? Anusri, can you tell me? Or anyone? Once you know this equality, can you tell me that why we can write maximum here instead of supremum? So that means that the supremum is attained. Yes, Saurya, tell me.
सर फाइनाइट आइगन वैल्यूज हैं तो मैक्सिमम होगा जो वो सेट में ही होगा, मतलब
ये I
अनकाउंटेबल नहीं.
that when x varies over unit ball, why this supremum is attained?
सर क्योंकि ये आइगन वैल्यू पे डिपेंड कर रहा है.
वह कहाँ कर रहा है आइगन वैल्यू पे डिपेंड? वो तो बात की बात है, अभी कैसे पता चलेगा? Because this defines a हाँ, सौविक नंदी बोलो.
सर इस साइड में तो सिर्फ पॉलिनोमियल आएगा ना, तो कंटिन्यूअस फंक्शन होगा.
Continuous function over compact set attains its bound. So the simple reason is that, so x is a non-zero vector. This is equal to max of x transpose mx, where, so this is for any matrix. Okay, ये सिमेट्रिक हो या नहीं हो जरूरी नहीं है. सो ये आप समझ गए, ये तो क्लियर है. देखो ये वाली डायरेक्शन, right? This direction is clear. I mean to say, just forget about max first. So this is a subset of this, right? Yes or no? And by this way, you can show that this is also a subset of this. Okay, so their maximum will be equal. Is it okay? I'm not going to write that. सबको समझ में आ गया ना? Now see, if M is a symmetric matrix, suppose that M is a symmetric matrix, then it is orthogonally diagonalizable, right? M is orthogonally diagonalizable. Okay, so there exists a P such that P transpose and P is equal to a diagonal matrix D, where the diagonal element are the eigenvalues of M. Okay, so you know that already, right? So symmetric matrices are orthogonally diagonalizable, right? Okay, so screen is frozen. Okay, so now you can see it. So see, this thing x transpose mx, this number is equal to, or I can say that p transpose maybe, yeah, pm p transpose. Okay, फर्क नहीं पड़ता ना उससे. So x transpose, in place of m you can write p transpose d p, right? X, is it okay? Because m equal to p transpose mp. P and p transpose will be inverse to each other because the matrix is orthogonal. Okay, p is an orthogonal matrix. So now see, xᵀA², this is a vector, right? px transpose. So I will give you a little exercise here. Suppose P is an orthogonal transformation write it. P is a orthogonal matrix, then norm of px equal to norm of x. Okay, norm preserving is norm preserving transformation. होता है या नहीं होता है? ऑर्थोगोनल मैट्रिक्स नॉर्म प्रिजर्व करती है, बताओ anyone? So do you know that it preserves norm? Okay, so see, this will be equal to, now tell me, so what will be this now? Px transpose dpx. So this sum will be, this is, isn't it eg sum I goes to 1 to n, where lambda is our eigenvalues of m xi square. Yes or no? Tell me. Okay, put the maximum eigenvalue. This is your homework. अगर हर जगह, if you replace lambda I by lambda max, you get this, right? Lambda max of m. Okay, so no need to write m. Lambda max denote the maximum eigenvalue, and you know summation x square is, this sum is equal to, if we choose the unit vectors, this sum is equal to 1. So this comes out to be lambda maximum. Okay, so the upper bound of this set, it is lambda maximum, the largest eigenvalue of m, in case m is symmetric. Is it okay? है ना? किसी को समझ में नहीं आया तो पूछ लो हिंदी में भी. Okay, so see, calculation is clear, right? There is nothing very difficult to understand here. Everything is okay. So here what I did, that you know, lambda, so we say that lambda is the maximum eigenvalue, so this is put lambda max everywhere, so this will be greater, right? And you know the unit vector norm is 1. If norm x is equal to 1, then this sum is equal to 1. So it means that lambda max is a upper bound, and this upper bound is attained somewhere. बताओ फिर, anyone, where it is attained? Let me know. Anyone? Yes, Kinjal?
Unit eigenvector corresponding to lambda max.
Right. So we can assume that the lambda 1 is maximum, right? Without loss of generality, right? We can assume that the lambda 1 is maximum. So ये क्या आ जाएगा? This will be norm x equal to 1 is less than lambda max, and without loss of generality, lambda max equal to lambda 1. So lambda 1 is attained at E1. Okay, at E1. If you put E1 here, then you will get lambda 1 only, right? So see it, if you put E1 in place of x transpose, E1 transpose ME1, then you will get, what you will get? Lambda 1, right? x1 square, that is 1 square. You get lambda 1. So for symmetric matrix, it is the largest eigenvalue. Okay. So this thing you should know. And it's not difficult to guess in the exam also. Okay, मतलब एग्जाम में सोचना ये डिफिकल्ट नहीं है, ये चीजें पड़ी हुई हैं ऑलरेडी. फंक्शनल में भी था ये सब कुछ, फंक्शनल एनालिसिस के कोर्स में. And what I told you, that TIFR आप पार्ट ए का 13 क्वेश्चन या 14 क्वेश्चन देखिएगा in the TIFR 2024, then you will see that here also. So and GATE 2026 maybe this kind of question is also there in GATE 2026. Okay, so if you know that this will be the largest eigenvalue, then you can do it. Now how to solve this question? Okay, we know that A is symmetric, then A inverse A square and A inverse is also symmetric. See, A is symmetric matrix, so A square and A inverse is also symmetric. Once we know the eigenvalues of A square and A inverse, then we can solve it, because we have to choose only the maximum eigenvalue. And to know the eigenvalues of A and A square, what do we need to know? The eigenvalues of A, right? And you could do that. So what is the eigenvalues of A? Could you please calculate? Go fast and calculate it. Is equal to lambda max of maximum eigenvalue. So what are the eigenvalues of A? Dear all, let me know. So the characteristic polynomial is, so you tell me, it's your work. Anyone? Calculate the eigenvalues and let me know. Hello Lakshmi, can you hear me? Hello Srinivasa. Can you hear me?
Sir.
Okay. So please calculate it fast. What are the eigenvalues of A? Find the eigenvalues of A, dear students. So I think I should work.
So 2 and 2 plus root 2 and 2 minus root 2.
2 plus root 2 and 2 minus root 2. Okay. So eigenvalues of A square is square and A inverse. So of A square will be 4, 2 plus root 2 square, 4 plus 2, 6, 6 plus 2 root 2, right? No, 4 root 2, right? Let me know. And I need the maximum, so I don't need to calculate the another one. And the eigenvalues of A inverse will be 1 by 2, 1 by 2 plus root 2, and 1 by 2 minus root 2. So this will be the maximum, by the way. So what will be its answer? 2 minus root 2. plus root 2, 2 plus root 2. That will be 2 plus root 2 and 4 minus 2, right? 2, 1 plus root 2. Okay, so this is the maximum eigenvalue of A square and this is the maximum value eigenvalue of A inverse. So this one is correct for A square, for A inverse. कोई गलती हुई है मुझसे? ओके, हुई है गलती यहाँ पे. So 1 plus root 2 by 2. Yeah, so it's easy to solve in the exam, right? Let me know how easy it was. But you should know all this, right? You will not be doing
root 2 by 2 आएगा.
1, 2 plus root 2 by 2.
plus
Right?
root 2.
हाँ जी. Okay, okay. Thank you. Right, 2 plus root 2. Okay. So any questions? किसी का कोई question है? Anyone wants to ask something about this? Please let me know. So I will provide you handwritten notes, also digital notes, okay? मतलब latex notes, where I will be writing everything, every step. And if you have any question, then I will also mention questions with answers. Let me know. Do you have any questions? So now, why could you not solve this question in the exam? Any one of you would like to answer it? That आपसे क्यों नहीं हुआ? आप बताओ कि भाई मुझसे इसलिए नहीं हुआ सर, मैंने क्वेश्चन देखा तो मैं तो देख के ही भाग गई या देख के भाग गया. एनीथिंग एल्स? Then I would also be able to know, right? कि प्रॉब्लम क्या है. कोई तो बोलो ये क्वेश्चन देखा था.
Sir, I previously, sir, I assume that this type of problems are sometimes so looking difficulty, sir. That's why I left this kind of questions, sir.
Okay, so you don't even try.
Yeah, sir. That's why I did wrong, sir.
Okay,
In
so you
further, I
did
need
not
to
waste
look
your
at
time
every.
at least. So anyone who tried to solve this question but could not solve it, anyone raise your hand? You tried to solve it but you couldn't, so all of you skipped it. So there is no harm, you have lot of options there. Okay, so but you could solve it also. Okay.